Hello everyone, I'm Mrs. Aparna More from Modern College of Engineering, Pune. Today we will be discussing about convolutional codes and coding methods, precisely code tree and sequential decoding. Convolutional codes consist of shift registers, mod 2 adders and multiplexers. The constraint length is defined as the number of shift registers. Here we see this is the convolutional encoder. There are 3 shift registers, so this is the constraint length, which is 3. G1, G2, which are the adders. G1 has mk plus mk minus 1 plus mk minus 2, and G2 is addition of mk and mk minus 2. V1, V2 are the outputs. Here we have the state table. I have described this state table in detail in the video of a convolution encoder. I'll quickly revise this. So we have mk as the input, mk minus 1, mk minus 2 as the states. To find out the next state, we have to pass on the contents of mk to mk minus 1, and mk minus 1 contents are going to mk minus 2 in the next state. So here 0 is moving to mk minus 1 and this 0 is moving to mk minus 2 in the next state. The output, addition of all 3. Addition is mod 2 addition, so we call it as mod 2 addition or XOR. So 0 XOR 0 XOR 0 is V1 and V2 is 0 XOR 0. Another one we'll take. Present state is 0 0, input is 1. So there are 4 states A, B, C, D. A state is 0 0, B state is 1 0, C state is 0 1 and D state is 1 1. So for each state there is a combination of 2 inputs, 0 and 1. If you see, all the states have a combination of 0 and 1. Here I'll randomly take this one. The present state is 1 0, input is 1. So the next state will be 1 will be going to mk minus 1 and this one is going to mk minus 2. So the next state is 1 1. The output is 1 XOR 0. V1 is 0 and V2 is 1 XOR 0, so it is 1. Likewise, we have to prepare the whole state table. We move on to the next, the code tree. With the help of the state table, we are going to prepare the code tree. So for this, we are at the initial state A, that is state A is 0 0 state. Now there is one thumb rule. If we have the input 0, then we move in the upward direction, and if we have the input 1, then we move in the downward direction. So the input is 0, we are moving in the upward direction to the next state 0 0. So it is going to state A 0 0 and the output 0 0 is written here. So this is the output. The next is, we are at state A, the input is 1. We are going to the next state 1 0, that is state B, and the output 1 1 is written here. Similarly, we have here state A, that is 0 0, input is 0. We are going to the next state A and output is 0 0. A state, if input is 1, we are going to the next state, that is B, and the output is 1 1. As of now, do not concentrate on it. I'll explain to you later. At state B, that is 1 0 state, if the input is 0, then we are going to the next state 0 1, that is state C, and the output is 1 0 written here. Then we are at state B 1 0, if the input is 1, then we are going to the next state D, that is 1 1, and the output then is 0 1. So it is written here 0 1. Similarly, the next, that is at point A, at state A, if input is 0, then we go to state A. If input is 1, then we go to state B. For state B, if input is 0, then we go to state C, and if input is 1, we are going to state D. So we will concentrate on state C and state D now. So only concentrate on this particular part. So at present state is C, input is 0. The next state we are going to is A, that is 0 0, and output is 1 1. C output is 1 1. Present state is 0 1, that is C state. Input is 1. The next state we are going to is 1 0 and the output is 0 0 written here. Then we are at state D. Now see only this part. We are at state D. Input is 0. We are going to the next state 0 1 and the output is 0 1. We are at state D. Input is 1. We are going to the next state, that is 1 1 and the output is 1 0. So similarly, it is a repetition of all the same what we have seen. A is going to A, B, B is going to C, D, C is going to A, B and D is going to C, D. Similarly, it is a repetition ahead. Now we have the reflection spot. A reflection spot is where a question will be asked and I'll take a pause. The options are given to you. You have to answer the question and we will discuss the answer after the pause. So the question is, if the input is 0, then in which direction should the encoder travel from present state to the next state? Options are downwards, upwards or none of the above. So I'll take a pause. So the answer is, if the input is 0, then we travel upwards. Moving on to the next. Now here, there will be one doubt in your mind that how many bit periods are we going to repeat this. So the input is given to us 1 1 0 1 1. We have to find the output for this particular input. So as there are 5 bit periods, similarly there are 5 times you have to repeat this cycle. So for this particular input, we will be finding out the output. So we are at the initial position. The input is 1, so we move in the downward direction. The output is 1 1, which is written here. Then next we are at this position B. The input is 1. We are traveling in the downward direction. The output is 0 1, written here. Then input is 0, so we are traveling in the upward direction and the output is 0 1. Then next input is 1. We are traveling in the downward direction and the output is 0 0. Input is 1. We are traveling in the downward direction and the output is 0 1. So for input 1 1 0 1 1, the output is written as 1 1 0 1 0 1 0 0 0 1. Now this is the basic block diagram of the communication system, the transmitter and the receiver. We have given some input, we got some output U. We will be sending that output signal to the receiver input, which is the received signal, and we have to find out the original sequence back. So for this is the sequential decoding of the code tree. So we'll directly go to the code tree. The receive sequence is given here Z, which is 1 1 0 0 0 1 1 0 0 1. This is not same as the transmitted output signal. There are some errors. We have to find the original signal. So here we are at this position. Now what we do is we compare the receive sequence with the output. Now we have considered only the lower part of the code tree and not the upper part. Why? Because this 1 1 output is compared with the receive sequence. If it matches, then we are going to travel in this direction only. So this 1 1 is matching with this 1 1. Then we are at over here at time period T2. The receive sequence is 0 0. There are two paths having output 1 0 and 0 1. None of the branches are having 0 0. So by default we choose the upper path. Over here we can see this 1 0 and 0 0 have a difference of 1 bit, that is the first bit is different. So the disagreement count is 1, which is written here. Then the next is 0 1 is the receive sequence. Again here we see two output paths, that is 1 1 and 0 0, which are not matching with 0 1. So we choose the upper path by default. And if you compare 1 1 with 0 1, the first bit is different. So this disagreement count is 1 plus this disagreement count, that is the total disagreement count will be 2. Now here again there are two paths and it is compared with 1, 0. None of them are matching, so we choose the upper path and the disagreement count will be 1 plus this 2 and it is going to be 3. Now the criteria is, if the disagreement count is 3, then we turn around. So we are going to turn around and move on to the other branch. So we are moving on to this branch. If you compare this 1, 1 with this 1, 0, the difference is 1 plus this 2, that is the disagreement count is 3. So we turn around and choose the downward path. Here again at this time period T3, 0, 0 and 0, 1, if you compare, there is a difference of 1 bit. So this disagreement count of 1 plus 1, total is 2, which is written here. Next at time period T4, 1, 0 is compared here. It is matching with this upward path and disagreement count is 0 plus 2, so it is 2. Again here 0, 1 is not matching with either of the two, so choose the upward path with a disagreement of 3. Then choose, as the disagreement count is 3, we turn around and choose the lower path. Again if we compare this 0, 0 output with receive sequence 0, 1, the disagreement count is 3, so we turn around and we are not going for this one because this 0, 1 and 1, 0, here both the bits are different, so disagreement count over here will be 2 plus 2, which will be 4. So we are not going for this path. We are choosing the lower path here. This at time period T2, 0, 0 is compared with 0, 1. The disagreement is 1. Here 0, 1 is matching with this upward path. So we are going here. The disagreement count is 1. This 1, 0 is supposed to be compared with both the paths. It is not matching. So we choose the upper path having a disagreement of total count 2. It is again going to the next, that is 0, 1. So the disagreement count here will be 3. We turn around, move on to the lower path. Here also the disagreement count is 3. So we turn around back and choose this path. This 1, 0, 0, 0, disagreement count is 1 plus 1, that is 2. And here 0, 1 is already there in the lower path. So we choose this path. So this is going to be our receive sequence. Total disagreement is 2. So the green color line is the one which we have traced. This is a receive path. Now we will see how we are going to find out the original sequence. So we are at this position. The receive sequence is the green color path you have to concentrate on. So if we are moving in the downward direction, the input is 1. So here it is written 1. Again the green path is moving in the downward direction, so 1. The green path is moving in the upward direction, 0. In the downward direction, so 1 and a 1. So the original sequence 1, 1, 0, 1, 1, which is the output of the receiver, which is same as the input. So this is the decoded signal what we have obtained. So the reflection spot is, what should be the maximum disagreement count after which the decoder should turn around? The options are given. I'll pause and then we'll discuss the answer. So yes, the maximum disagreement count should be 3, after which we should turn around. So we have seen the code tree and the sequential decoding, and sequential decoding is basically trial and error method, and we have performed this and we have seen how to find out the decoded signal. So the references I have referred is Digital Communication, Fundamentals and Application by Bernitz-Sklar. I hope you have understood this concept well. Thank you very much.